All right, so let's get started. You guys had the midterm, a few quizzes, and of course we've already covered quite a number of topics. I think for me, the most challenging topics in this class, especially this early, start of the semester, we're still doing some basic steps in our Java class. And here in CIS 123, as I cover the interface and polymorphism is always very challenging because those are sort of advanced topics, and the purpose is very specific for both polymorphism and interfaces. So we're going to kind of cycle through iterations of covering this. And this will overlap a great deal with also material covered in our Java class. So I think we're basically after midterm. We're beginning another cycle of this iteration, going back through the basics, looking specifically at the functionality of individual classes, and also going a little deeper into examination of relationship between classes. And today I'd like to look at many different examples, or as many as possible. Okay, so officially the first presentation I'd like to go through on the outline is week 6. So we can go to this, talking about the scope and visibility of components of the class. So just a quick review of what we already said about the class. Classes, of course, represent concepts, right? Examples of classes could be physical devices. For instance, if I wanted to model the functionality of a printer, right, I could have components of the printer. I could have a paper tray, the electronic parts of it, the drum, if it's a laser printer, and all kind of internal physical components. Those could be easily modeled because typically you can basically detach it from the device, examine it in your hands, and think about individual properties and individual responsibilities of these components. So it's very easy to deal with physical components, and they're very easy to abstract them as classes in software. That's typically a very simple thing to do because they're so well defined and easier to examine. Another example of a class could be, for instance, if I say I want to go to a register of motor vehicles, or I could say I brought my car to the register of motor vehicles. Well, that's really not 100% true. I mean, I didn't take my car and walk through the doors with my car. Obviously, I brought my registration with me, perhaps, if I needed to work on something at the register of motor vehicles. So therefore, this paper, this registration, a legal document or contract of some sort, becomes a candidate for a class. So sometimes you're talking about a physical thing, but in reality you're dealing with some sort of technicality or legality of it. So driver license, registration, insurance policy, all of those things, any kind of contract, any sort of document that ties in other parts as legal obligations, which typically good news, by the way, to a programmer, because they have quite unique identifiers and already the whole preset set of attributes. So those are also great candidates for classes. Another typical category of classes is something that we call business objects or business classes, which become business objects at runtime. For example, with the bank accounting sample that we went through already, we talked about the possibilities of deposit and withdrawal. So deposit and withdrawal are just sort of like use cases within our application, but it's okay to represent them as individual classes. Instantiate a deposit class, an object of that class, or a withdrawal, and see how it can progress through a transaction, right? So this is just a business class which is necessary for the duration of the transaction as we keep processing it. We're trying to interact with the user, so maybe there's some sort of like a user screen that the user is trying to interact. It could be in the browser, or it could be at a location at the automated teller machine, but the user interacts. So somehow this interaction is delivered to the business object. The business object sort of like validates that, and it could delegate the validation and other parts of the transaction to other objects, right? But eventually perhaps it connects to the database, commits a particular transaction, and then reports that everything's okay, or maybe it's not okay. So this is an example of a business object. Other types of classes which are extremely popular with programmers, something that we really need is some sort of a collection. Very often you don't deal with just individual single instances of your classes in, say, in a gaming environment or in business application. Well, typically in a gaming environment you have a collection of game characters, scenery, moving objects, stationary objects. They're all can be classified, they all can be put in a collection. So some sort of array or collection or list of things is a great candidate to become a class, right? Oftentimes programming languages come with the libraries of classes that represent collections that you can use over and over and over and over again. For instance, in Java, if you have an array class, an array object, then why would you try to reinvent it every time you start a new project? You already know it's there. If it's appropriate to use, you just start using it. So, otherwise, when we look from so this is from the application design perspective. When we look at the class from the programming language perspective, for the programming language, it's of course is a blueprint of an object. Yes, question.
In Java, is util the class or is scanner the class?
The scanner is the class. The util is the name of the library package, which sort of like hosts that class. It was decided early on, as opposed to keep all of the library objects in sort of like one bag, instead subdivide into the so-called packages.
Like a normal library would do. All the mysteries are here.
Yeah, partitions. Yeah, parts, subdivisions, any of that nature. In fact, in C++, instead of packages, C++ using something called namespaces. But essentially it's the same thing. However, Java is sort of like stricter in this sense because, as you already know, the packages have direct correspondences to the folders in which the things reside. In C++, it's only an abstract notion. You can have your files anywhere you want. It's only in the source code. They're sort of linked together and as a single namespace. Well, good question. Yes, scanner in Java would be an example of a class, and also class name, of course. And util, Java util, it's where that thing resides in terms of the part of the library. All right, let's